Hello everyone, welcome back to Through Deviations. So in today's video of single variable calculus, we are going to be doing a little bit more of Newton's method to kind of wrap off our study of differential calculus. So this example will be used to approximate some constructible irrational numbers. So we can use Newton's method to not only approximate our rational zeros, but also our irrational zeros. So we're going to be looking into that today, but more in the context of approximating a number, numerically, of course. So if we remember, right, if we take an infinite number of approximations, then that's going to give us that number that we're looking for. But of course, that's probably going to be unreasonable because nobody is going to spend their entire life and probably infinitely more time trying to converge a decimal approximation. That would be a pretty sad life, I think. So why don't we just do a little fraction of that today, and we will be approximating the square root of 2 through a 6th order Newton's method approximation. So we are going to use the so-called appropriate x1. And appropriate x1, of course, means that we're not choosing something like unreasonably far away from the square root of 2. We're not choosing a minima where our slope is 0. We're not choosing a maxima where our slope is 0. We're not choosing somewhere where our slope is going to be really shallow, because that's not going to give us a good approximation in the first place. So we are going to look at a reasonable x of 1. So let's find a reasonable x of 1. I think a reasonable x of 1 here is going to be 2. But before we think about that, we need to think about how we're going to construct a function that we're going to differentiate to plug in to the Newton's method formula. So if I have that, if I want to find the square root of 2, right? Let's set that equal to x. So a good function that we could choose is x squared equals 2, or x squared minus 2 equals f of x. That's going to be a good function that we can use to approximate. So we're actually going to use that function. So f of x is going to be x squared minus 2. And so our f prime of x is going to be 2x because we just differentiate that. And of course, that's just a super easy monomial that we can use the power rule with. Now that we've found our functions and our derivatives, why don't we pick an x of 1? So I think 2 is going to be an appropriate x of 1. So let's try that. So x of 1 is going to be equal to 2. So of course we know our formula. So x of 2 is going to be 2 minus 2 squared minus 2 over 2 times 2. And that's equal to 1.5. Now, of course, I would hope that you follow along with your calculator maybe, because this is probably going to be pretty tricky to deal with without a calculator. So now for our x of 3, we're going to take 1.5. We're going to do 1.5 minus 1.5 squared minus 2 over 2 times 1.5. That's going to give us 1.416. All right, so now we have our x of 3. Let's find our x of 4 and x of 5 here. This might be a little bit tricky with all of the decimals we're going to be dealing with. So we have x of 4 is going to be 1.416 minus 1.416 squared minus 2 over 2 times 1.416, and this is going to be 1.414. So as you can see, our approximations are beginning to converge. The difference between our different approximations is getting a lot smaller, which means we're getting closer to an approximation. So now we're going to take x of 5. So x of 5 is going to be equal to 1.414 minus 1.414 squared minus 2 over 2 times 1.414. That's going to be equal to 1.41421. All right, so now we're at the home stretch. We're going to take our final approximation here. And this approximation is going to be for x of 6, our 6th approximation. So x of 6 is going to be equal to 1.41421 minus 1.41421 squared minus 2 over 2 times 1.41421. And from that, we're going to plug in every single decimal we get from our calculator. They may give different levels of accuracy, but this is what my calculator spit out. I got 1.414213562. And of course, now we can check our work to see if our approximation worked. And of course, we can just Google what the square root of 2 is. We can see how accurate our approximation is. So when I looked it up, I found that the square root of 2 in its decimal form is equal to 1.4142136237309.5. And of course, this repeats going on and on all the way out into infinity. All right, and we can see just how accurate our approximation is. We made a really accurate approximation here, and this is to the 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal points. So that is a pretty good approximation, I would say. All right, so I hope this was kind of a fun exercise, getting to look at some of the values of irrational numbers in decimal form. We probably don't do that very much. This is something that's probably a little bit farther outside of a calculus curriculum, but we like covering this kind of stuff here on 3 Deviations. So in the next video, as I said, for a while, we are going to be switching gears to a new method of calculus, but I recommend that we do not forget differential calculus here. We should remember it, and I might make a review video next that makes sure that we remember all of our derivative rules, but we will be saying goodbye to differentiation for a little while, and you will see what comes next in the next video. Thanks for watching. See you in the next one. Bye-bye.